Alrighty, let's go ahead and get started today. So before we get into talking about polarization and such, I wanted to let everybody know, in case you didn't already hear, tomorrow is the LAMP STEM Research Symposium. Some of you may be participating in it, giving presentations and stuff, but for those that aren't and don't know about this, tomorrow is an opportunity for a lot of the undergraduates, a lot of the students in the School of STEM to show off the research that they've been doing either over the semester or over the years. They'll be doing presentations, talking about the kind of research they do, what have they found, what are the future prospects for the research, or where can it go, things like this. And it's a bit of a competition, but also a bit of just camaraderie and sharing with everybody the things we've learned, because obviously it's these science topics, these subjects are vast, and no matter how long you stay in school and how much you study, there's only so much you will ever know. And generally speaking, you specialize in a very small area. And so there's lots of areas that you don't know that much about. And so you rely on things like this, whether it's reading articles or going to lectures and things like that, where people who are experts in that area can tell you what they know and inform you. And that way we all grow and learn from each other's hard work. So tomorrow, I believe it starts at 9. And I think it runs all the way till 4, but I think between 2:30 and 4 o'clock is the awards ceremony. But officially it's from 9 to 4. There, it's in PSB, the George's auditorium is where the presentations are usually held. So I advise everybody, especially if you don't have class, and a lot of the teachers should be letting students off to be able to participate, but not everybody is, so I can't promise it. But if you do have the ability, come by, watch, participate, learn a little, and also remember that even though you may not be giving a presentation now, you may be next year or the year after. And so by seeing how it's done now from the audience perspective, that'll be a great benefit for when it's time for you to give a presentation. You'll know what the audience expects, what to look out for, how to present yourself, because being in the audience is a much different thing than being the speaker. And you have to know both ends of it to be able to do a good job. And so come by, check it out, participate. I know they break for lunch in the middle, but so that's going on tomorrow. So if you can, please come by and join us, join into the crowd, let everybody who's given their presentation see that there's a big audience wanting to listen to what they have to say. So that's tomorrow. For us, of course, we are going to continue what we started before the Easter break, which is talking about polarization. Now, just to refresh our memory, polarization is defined as basically the direction that the electric field oscillates. So if you remember light, it's electric and magnetic fields that are oscillating together, perpendicular to each other. And that thing propagates throughout space. And that is what we call light. And of course, the electric field does not have to always oscillate up and down. That's how we draw it usually, but it could propagate it, oscillate in any direction. It could be oscillating left and right, up and down, back and forth, at an angle. And so we have defined which direction that the electric field oscillates in to be called the polarization angle. All light, of course, since all light has electric fields that are oscillating, all light is polarized. And so one way we show it, or the way I'm going to show it in this class, the symbology, is quite easy. If the light is polarized up, I just put a little up arrow. There's light, and I'm saying this light is polarized upwards, okay? And that means the electric field is oscillating up and down. If light is polarized horizontally, I say it's polarized horizontally, like that. Very easy. And there's another thing, which is light that's called unpolarized. Now, this is a misnomer because, as I said, there's no such thing as light that is not polarized. If light has an electric field, which it does by definition, it has a polarization. What we call unpolarized light is when you have a source sending out light. Some sources, when it sends out light, the light is always polarized in the same direction. So you may have a light bulb or something, and however it works, when it produces light, the electric field is always upwards. Or you have a different light bulb and its electric field is always at a 30-degree angle. And so we say this light is polarized this way. Unpolarized light is when you have a source that sends out light, but each piece of light it sends out is polarized in a different direction. So you may have the first particle of light come out and it's polarized up, and then the next piece of light that comes out is polarized to the right. So it's not all in the same direction, it's just randomly polarized. That's what we call unpolarized light. It's random which direction each piece of light that comes from this thing is polarized. And an example of that is the sun. The light that comes from the sun is randomly polarized. And so we say the sun sends out unpolarized light. But just know it's not really unpolarized, it is polarized. It's just every piece of light you get from the sun is in some new direction. So half of it is up, half of it is to the right, let's say, is one way of thinking about it. And the way I show that symbolically is like this, okay? So half of it's upwards, half of it's to the right. You don't know, it's random. This is unpolarized. This is vertical. And this is horizontal, of course. And if we want to go by angles, vertically polarized, we'd say it's polarized at 90 degrees because, you know, the y-axis is 90 degrees. Horizontal, of course, is 0 degrees. And unpolarized, since it's random, we don't have an angle for it. So all light has some polarization. Even if we call it unpolarized, that just means it's random. And what we started talking about last time was, what if we start sending this light through what's called polarizing filters? A little lens or a piece of plastic or a film or something which allows light to go through if the light is polarized in the correct direction. If it's not polarized in the correct direction, then it's blocked, like it can't get through, like it's a wall or something. Those are called either polarizers or polarizing filters. Or polarizing films, bunch of different names for it, but a polarizing filter is some piece of material that when you send light through, if it happens to align the correct way, the light can pass through as if it's invisible. If it's polarized in the opposite direction, that is perpendicular, then it's blocked completely. And if it's somewhere in between, then some of the light can get through and some cannot. And so what we wanted to do, what we started last time was we wanted to have an equation so we can predict if I send this light through this system of polarizers, what will get through, how much light is going to make it through. And we said that the equation that does this for us is called the Law of Malice. Okay, the Law of Malice is an equation that tells you, given some intensity of light, a brightness, how much light you start with, if you send it through a polarizer that's polarized in a certain direction, how much light will you get out? What's the intensity of the light coming out? And it says the intensity coming out is the intensity you start with times cosine squared of the angle. And the important note here is this angle is the difference between the light coming in and the polarizer, the filter. Okay, so you'll have some light. Let's say the light is polarized up. That light wants to go through a filter, and the filter, let's say, is polarized at 30 degrees. The way we would show this as a problem, we'd say, okay, we start with light. The light is polarized up, and here's our filter. And the way I draw it, this is me. This is not a standard or anything, so everybody does it slightly different. I say this filter has a polarization at an angle, and that's how I draw the angle, and I tell you the angle, 30 degrees for this filter. Okay? It could be 60 degrees, it could be 45, whatever. In this case, I start with light polarized up. I'm trying to get through this filter that's polarized at this angle, and I want to know how much light gets through. So the way we do it, quite easy. We say the intensity of the light that gets through is whatever we start with. Well, this is a number, right? Depending on the source, is it a bright light bulb? Is it a laser? Is it the sun? All these different things start with different intensities. How bright is the light? I don't really care. So for all of our problems, I'm just going to leave the intensity, the initial intensity, as this symbol I naught, initial intensity. So I start with I naught. It's some number. We don't care what the number is. Leave it as a variable. And that intensity, that light, is trying to get through this filter, and I want to know, what do I see coming out? So we start with some initial intensity, then cosine squared of the angle. But here's the important part. The angle is not the angle of the filter. Okay? It's very tempting because obviously the equation is theta, and I only see one angle here, so I should use 30. But no, the angle we use for this is we start with 90 degrees because it's polarized up. So the initial light, the light that's coming in, is already at 90. And what is he trying to get through? He's trying to get through 30. So we're going from 90 to 30. We take the difference, we subtract them. 90 minus 30 is 60. So 60 is the angle we use for this problem. Okay, it's always the difference. What's the light coming in? What angle is he? What's the light trying to get through? What angle is that? Subtract those two angles. That's what we put into cosine. Okay, any questions about that so far? All right, well, once we have this, all we have to do is plug it in our calculator, and we get cosine squared of 60 means cosine of 60 times cosine of 60. Okay, cosine of 60, I believe, is 1/2. So 1/2 times 1/2 is 0.25 times I naught. So how much light makes it through? 1/4 of the intensity that it started with. So if it was a light bulb, certain brightness, you put this filter over it, only 1/4 of the light can make it through. 0.25, 25%. And that's it. Very easy. If you know the initial light, polarization angle. You know what you're trying to make it through. You subtract those two angles and you do cosine squared of that thing. Question?
So if what was it? I'm sorry.
Mhm.
If it was in a horizontal situation and that'll be 0, would you subtract 0 minus the angle? Would it be the angle minus 0? I mean, would it be a negative or a positive? I'm sorry.
Yeah, okay. Very good question. So because when I'm using these directions, I'm saying up, but we know a wave actually is up and down, right? So the fact that it's up at 90 or down at 270, it's the same thing. But instead of writing both up and down, I always just write it as up and I call it 90. What that means is whenever you're going to take the difference between angles, whatever the difference is, make it positive. So in your example, let's say we start with light that's horizontal and I try to get through this guy that's at 30. Exactly the same problem, but now the light starts horizontally instead. Okay, no problem. What do? We say I, the intensity that makes it through, is whatever we started with, I naught times cosine squared of, well, our initial light is horizontal. That means it's at 0 degrees. We're trying to go from 0 to 30. So we say 0 minus 30. Well, is it 0 minus 30 or is it 30 minus 0? Right? Because 30 minus 0 is 30, but 0 minus 30 is negative 30. It turns out it doesn't matter. And the reason it doesn't matter is because we're talking about the cosine squared. And that makes anything that would have been negative will become positive anyway. So when you go to subtract these angles, I did 90 minus 30 to get 60. So here I should do 0 minus 30 would be negative 30, but I just call it 30. Don't worry about the negatives. It doesn't matter which order you subtract them. You just subtract them to get a number, and that number just make it positive every single time. So this would be 30. Okay. So does that answer your question?
Right. So nothing is in these type of problems. There is no such thing as a negative number that we will put in this because
right.
the square is gonna automatically make it positive anyway.
That's exactly right. Because that would be weird, right? What would it mean? Well, we have a negative intensity coming out. That would be something kind of strange to even think about what that would mean physically. No, everything, even if you wanted to put a negative 30 as the answer in there, you're still going to be squaring at the end of the day. Plus, there's another thing, which is a mathematical thing, which is that the cosine function is what's called an even function. And so what it means is the cosine of 30 is the same as the cosine of negative 30. So it doesn't matter if you put a negative angle or a positive angle, the answer is the same number either way. So for both reasons, the fact that we're using cosine, the angle, whether you make it positive or negative, you get the same answer. And then on top of it, we're also squaring it. So it'll be positive no matter what. So yeah, every time you do this, subtract the two numbers. And if you want to think about it, the easiest way is take the bigger and subtract the smaller from it. So in the first one, I did 90 minus 30. In the second one, I'm doing 30 minus 0. Just to make sure I never get a negative number. It'll always be positive. And so your answer will always be a positive number or 0. Now, there's another thing we need to worry about. And that is this unpolarized light thing. Because right now I'm doing examples where we have light that's polarized in a certain way, and that has to get through the filter. And so we say, okay, we started at this angle and we're trying to get to this angle. But if our initial light is unpolarized, we don't know the angle. How do we handle this? Well, this is what we're going to do. Here's our problem. Unpolarized light is trying to get through a filter, which is, let's say, polarized upwards. And the question is, how much light makes it through? Again, this is a simple I'm going to use for unpolarized light. So how do we do this? Because in order for me to use the law of malice, what I want to do is figure out what is this angle that goes in here. But I can't because I don't know the first angle. Of course, the filter I know because it's upwards has to be 90, but I don't know the initial light. So here's the good news. It's very easy. It's always the same answer. No matter what, if your initial light is unpolarized and you put any filter in front of it, I don't care what the angle of the filter is. It could be up, it could be to the right, it could be at an angle, it doesn't matter. If you put a filter in front of unpolarized light, the answer is always 1/2. It always blocks half the light. So in this case, 0.5 I naught or 1/2 I naught would be the answer. I don't even have to do the work. I know immediately. I start with unpolarized light. I put a filter next to it. The light that comes out, half of it is blocked instantly. And so half makes it through. So that's one time where you don't care what this angle is. It doesn't matter at all. That could have said 31 degrees and I'd still have 1/2 as the answer. Okay. So this is a law of malice. We start with light. Either it's polarized in a certain direction or it's unpolarized. We're going to put filters in front of it and we want to know what do we get out the other side. And this is how we're going to do it. Now, of course, it gets slightly more complicated because I've only done examples with one filter. But there's nothing stopping me from putting a second filter after the first one, or a third, or a fourth. And so now I could send light through a series of filters. How do I handle that? How do I take the law of malice, which has one angle in it, and now do a system that maybe has 2 or 3 filters? Well, we modify it just slightly. Very easy little modification. Here's an example. Light polarized upwards. I want to go through a filter that's polarized. Let's say this one's at 30 degrees. And then we have another one that's polarized horizontal. And of course, the question is, how much light makes it through this system? That's always the question for polarization. Well, I could, of course, just give you, tell you exactly what to do, but I want you to see why this is what you should do. Think of it like this. Forget about this second filter and only think about the first filter. If that's all we had, then the answer would be the intensity that comes out is the initial intensity times cosine squared of our initial light started at 90 degrees. We're trying to get through something that's at 30. So 90 minus 30 is 60. And so this, whatever this is, this number is the amount of light that makes it through the first filter. All right. What happens to the light? Well, if the light made it through the first filter, here's a rule. The polarization of the light that makes it through a filter is always the same direction as the filter. So my light started polarized up. Okay, no big deal. I tried to get through a filter that's polarized at this 30-degree angle. Now, some of it is blocked, but some of it makes it through. Whatever made it through is now past the filter, but it's not in the upwards direction anymore. Now the light is at 30 degrees, just like the filter was. Because in order to get through the filter, it has to align in that direction. And so now what we have is light that's polarized at 30 degrees. How much light? Whatever this number happens to be. And now the question is, okay, that light is trying to get through the second filter. So how much will get through? Well, what did you start with? You started with this much. That's what made it through the first one. And now it's trying to go through another filter. So you have a cosine squared for him. And what is his angle? Well, this polarizer is horizontal, so he's at 0 degrees. What am I starting with? I'm not starting at 90 anymore. I've already done that. Now I'm starting with a 30-degree light. So now the light is trying to go from 30 through the 0 guy. So this angle is 30 minus 0, which is 30. And now, when I multiply all of this stuff together, I'll know how much light makes it through the whole system. I started with a certain amount, I naught. This much made it through. Whoops. Now that much made it through. That much now has to go through the second guy. So I now start with this much, and I have to make it through the second guy. So multiplying this out will tell me how much goes through both. Okay. Any questions about that?
So with this, do we solve for the first section first? And then once we get that answer, we multiply that answer by cosine squared of 30? Or do we
Yes.
put it on the calculator?
Yeah, that's a good question. It's whatever you're comfortable with. It doesn't matter, because since you're just multiplying all these numbers, the order doesn't matter. I wrote it like this, like they're separate things, so you could get a kind of a physical view of what's happening. But really, I could have just wrote I naught cosine 60 cosine squared 30. This is really all it is. Now, when I do this myself physically on a calculator, because cosine is a function button, and then there's the squared button, and then you have to multiply them, it's kind of a pain. So what I do is I just do cosine of 60, get an answer, then I multiply it by cosine of 30, and I get an answer. Now that's cosine of 60 times cosine of 30. Now I have to square it, because here's a little math trick. Cosine squared A times cosine squared B is the same as cosine of A times cosine of B squared. And I find doing this on a calculator is easier to type than trying to type cosine squared times cosine squared. But that's just my own little thing. You could do cosine of 60 squared, get a number, write the number down, and then cosine of 30 squared, get a number, write it down, and then multiply those two numbers together. Same thing. The answer is 0.1875. Okay. And then if you're really good with this stuff, if you're fancy, then you could say, well, look, cosine of 60 is a half. So cosine squared of 60 is a fourth. 1/2 times 1/2 is 1/4. And then cosine of 30 is square root of 3 over 2. So cosine squared is 3 over 4. So really, this is 1/4 times 3/4, which is 3 over 16. I naught. So I know some people really like fractions. And so that's the same answer. 3 over 16 is the same as 0.1875. It depends how you like doing it. My suggestion, just use a calculator. No big deal. Of course, make sure you're in degree mode. That's critical. You can't be in radians here. And however you want to type it in, whichever is best, go ahead and do it that way. If you want to do cosine of 60 squared, get a number and then multiply that number by cosine of 30 squared, fine. The way I do it is this way here, just because for me, typing in my calculator, I find this is a little easier to do, and I make less mistakes doing it that way. Okay, so any questions about this? And this is how we're going to do it. Any problem I give you, you'll have light polarized in some way or unpolarized. And then there's going to be a series of filters after. And the question will be, what comes out of the system? How much light makes it through? And if we have 3 filters, then you have I naught cosine squared of the first one, times cosine squared of the second, times cosine squared of the third. And the key where most mistakes are made is when you go do the second angle or the third angle, either you're using whatever this number says, which that's usually not right, or you do 90 minus 0. You go back to the original angle. But remember, once light goes through a filter, that light has changed. And so what's trying to get through the second filter is not the original light. It's this piece of light that has already made it through. And that light is always going to be at whatever the angle the filter was originally. So I started with 90. I go through a filter that's at 30. So that's cosine squared of 60, get a number. Now this light is now at 30 because it made it through the 30 filter. And so it's the 30 guy trying to get through the second filter. And then of course, from there, the light that gets through the second filter is now polarized horizontally because the second filter is horizontal. And so if he had to go through a third filter, this light is at 0, the third filter is at whatever, and you go from there. Let's do another example. Let's start with unpolarized light. And I want to go through an up. I want to go through a 60. And then I want to go through a 45.
So is this like, do you keep just adding on cosine squared, and subtracting?
Right, exactly. The way you handle more than one filter is you multiply in another cosine squared for the new filter. Now, I know you didn't mean it this way, but the wording, we have to be careful. We're not literally adding another cosine squared, we're multiplying.
Yeah.
Right. It's just a wording thing, but I want to make it clear for those that it could confuse, because that is a possibility. Do we multiply the cosines or do we add the cosines? In this case, we're multiplying them. Each filter gets a cosine squared. And so we're going to multiply each one. The angle that goes into cosine depends on what filter you're coming from and what are you going to.
So in this situation, would it just be 1/2 since this is unpolarized?
Well, let's see. I'll work it out and we'll see what happens. Exactly what you said is true, at least for the beginning. For the beginning, we're starting with unpolarized light. And the rule is, if you start with unpolarized light, the first filter doesn't matter. All I know is I'm going to get through it and I'm going to have 1/2 getting through. So what gets through is I naught, whatever we start with, times. The first filter, I get 1/2. I don't need a cosine squared here. And the reason I don't need cosine squared is because the initial light was unpolarized. If it were polarized like the previous one, I'd have to have a cosine squared. But here I don't. But now I've made it through the first filter. 1/2 of the light was blocked, 1/2 made it through, but what made it through now is polarized. And he's polarized the way this filter is polarized, which is up. So here's the thing. Now we're not unpolarized anymore. We've taken this randomly polarized set of light and we filtered out everything except for the up stuff. That's why these are called filters, because it's like taking a whole bunch of light that's in different directions, and we're only going to accept the light that's in the correct direction. In this case, the first filter only gives me up. So now the light is up. Okay, that means he's at 90. And what am I doing? I'm trying to go from 90 through a 60. So now I get a cosine squared of 90 minus 60. Okay. Then what? Well, now I've gone through the 60. Some light makes it through, whatever it is. And now the light is now at this angle. Which angle? 60 degrees. So now what I have is 60-degree light trying to go through a 45. Okay, so cosine squared for this guy, 60 minus 45. And then whatever's left, that light is now at 45. And how much? Well, this is where I get my calculator out. And I say, okay, let's see. I'm going to leave the half alone for now. This is cosine of 30. This is cosine of 15. Multiply them, square them. Then I multiply by a half. And my answer I get is 0.3499. I not.
So wait, you didn't multiply to 1/2?
I did this first. So remember, I'm doing this little trick here, but the 1/2 doesn't get squared. It's just 1/2. So I do cosine of 30 times cosine of 15, and then I square it. So that takes care of these two guys. And then I multiply that by this 1/2. And that's how I get this answer. Now, other people, when they're typing it in, they do 1/2 times cosine squared of 30 times cosine squared of 15. Same thing. It's just I got a weird way I type things in calculators because I know when I make mistakes and when I don't. So yeah, you do have to worry about the 1/2, but because these are getting squared and this doesn't get squared, I left him for last. I did these things squared first, and then I multiplied that thing by a half at the end to get the final answer. So there we go. This is as complicated as one of these questions gets. We have multiple polarizers at different angles, and we start with unpolarized light. So if you can handle this example, then any example I give you is actually easier. How do we handle it? The initial light is unpolarized, so that means whatever this first filter is, I don't care what that angle would have been. The first thing is a half. Now I'm through. I'm through the first guy. The light that made it through is whatever the angle is for the first filter. In this case, it's 90 degrees. Now that light has to get through the second filter. So cosine squared. Cosine squared of what? I'm starting at 90 and I'm trying to get through 60. So 90 minus 60 is 30. I've now made it through. Now I have light that's made it through. It's now at 60 degrees because it made it through that second filter. And that light is trying to get through one last filter at 45. So cosine squared. The angle for him, I'm starting at 60, trying to get to 45. 60 minus 45 is 15. There we go, all written out. Now I get my calculator and I start multiplying things together, and you should get something like this. So are there any questions about how to handle these types of problems?
I have a question, like just for clarity.
Sure.
So you don't subtract 90 from each one, like you go down the line. So it's like when we do it in this example, it went 90 minus 60 and then 60 minus 45. So it wouldn't be like 90 minus 45.
Right, exactly. Exactly. And the reason is because the way you want to picture it is this thing is its own little guy. And so for him, we have light that's starting at 90 and we're trying to get to a 60. And so that's why we do that. Once we've done it, we've made it through. And so now that light is no longer at 90 anymore. He's finished. The only light that made it through is what's at 60. So now we're starting with another set. This light starts at 60 and is trying to get to 45. Okay, so yeah, just because 90 was here, once we made it through that filter, that 90 is no longer there. Now the light is some new angle because the filter messed with them. And that's always the case. Once light gets through a filter, the filter tells you the new angle. And so you have to use the new angle now, not the original angle. And each filter will change it in some way.
Can you show me like step by step, like how you not like I know the answer, but can you show me how, like, can you write out how you did the cosine
Sure.
30 cosine 15 to get 0.3499?
Yeah, and it's possible I made a mistake, but let's see. What I did in my calculator is I said, okay, cosine of 90 minus 60 is 30. So I did that and I pushed, enter to get the answer. And now I have an answer. And then I multiply that answer by cosine of 15 and push enter. And now I have a new answer. Now I take that answer, whatever this answer is, and I squared it. And that gives me a new answer. And whatever that answer is, I just did 1/2 times that answer there.
Okay.
Okay, that's how I did this. And it's purely just because if I don't do it this way, then I have to remember all my parentheses correctly when I'm doing the squares and all of that stuff. There's just a lot of places, if you try to type everything in at once, some people are really good at it and they don't make mistakes. I tend to make mistakes if my parentheses are not perfect. So I try to do one little step at a time. So I do cosine of 30, get a number. Multiply that number by cosine of 15, get a number. Square that number. Now I've done basically cosine squared times cosine squared. Now that I have it, I multiply by 1/2, the last piece, and that should give me my last answer.
Okay, because I'm getting like this big fraction every time I put it in my calculator.
You're getting a fraction or a decimal?
I'm getting like a huge fraction.
Okay, well, your calculator may have a function in it that tries to only give you fractions. If it can give you a fraction, it'll give you a fraction instead of a decimal. And that's possible. Because I think, what is it? What's cosine of 15? There's a way of doing this where it's all fractions. What is your fraction? What did you get?
I got like 5. When I did, I got like 5 point something. Originally.
Okay, I see. Well, let me. Well, it's definitely going to be a decimal, something less than 1. It has to be. So let's see, cosine of 30. I'll do it again in my calculator. Cosine of 30 times cosine of 15, and then I square that thing. Then I multiply by 1/2. Yeah, I definitely get this. So yeah, I do cosine of 30, enter, and that gives me 0.866. Then that number I multiply by cosine of 15. So this is 0.866 multiplied by cosine 15, 0.8365. Then I square that, and that gives me 0.6997. And then 1/2 gives me 0.34987.
Oh, okay, I see. Okay, I think I know how to do it now. Cosine of 15. You said once you multiplied that by cosine of 15, you got 0.836.
Yeah.
Okay, I see that. And then you squared it.
And then I squared that number, and that gives me 0.699.
Okay. Oh, okay. I see how you did it now.
Yeah.
And then you multiplied that by 1/2.
That's exactly it. Yeah. Now, like I said, that's just how I physically type it in my calculator. If you have a better way of doing it, feel free to do it that way. It's just after years and years of doing this, both as a student and teaching it, I'm used to doing it this way, and that's why I do it. If it's confusing to anybody, don't do my way, do your way. That's fine. But certainly the answer, you should get this as an answer, or something very close if there's a little rounding somewhere. Now, just little tips that as I said, with experience, I've seen where people go wrong. The first place is the angle itself that goes into cosine squared. It's very tempting to just write whatever the angle is that's on top of the filter. Okay, that's not the angle. It's not what are you trying to go to. It's what are you starting at and what are you going to. So for this example at the top, we're starting with 90 and we're trying to get to 30. So I don't put cosine squared of 30 because it's a 30 filter. I'm at 90 trying to get through 30. The difference is 60. That's the angle. So that's the first place mistakes can be made, is what angle do I choose? Second, if you have multiple filters, when you go to the second cosine, the second filter, remember your light is no longer what it originally was. You've already gone through a filter, so it's changed. So the new light has a new angle. unless it happened that the first filter is the same angle as the first light. But in general, you've gone through a filter, the angle is now new. So that's the angle you start with for the second cosine. Here, I started at 90, went through 30, I'm now at 30. So the next cosine is starting at 30, going to 0. 30 minus 0 gives me 30. Another place, unpolarized light. I see it a lot where people forget you don't, like if this were, let's say 45 degrees here for the first filter, you don't need to do cosine squared 45. You just skip it. You get a half and then don't worry about what his angle is, except to say that once it makes it through, the light is at that angle, whatever it happens to be, but you don't have a cosine for the first filter if you start unpolarized. So little things I've seen in the past are, people do I naught times a half because it's unpolarized, and then they do cosine squared 90, for this particular example here. 1/2 because it's unpolarized, and then his first filter is at 90, and so I'll see that. But no, you don't need this piece. This takes care of it already. So it's a half because you went through the first filter, no matter the angle of the filter. Okay. And another thing, I sometimes see people square the half as well because it's cosine squared. So you think it's a half squared. No, it's just a half. Okay. And then one other tip, if ever you see one step and then the next step is perpendicular, okay, that's always 0. So if I start with light that's vertical and I try to get through the very next filter is horizontal, it's 90 degrees apart, it's always 0, even if there's other stuff afterwards. So if light is like this, and then I have a filter which is horizontal, and then I have a filter which is at some angle, and then another filter that's up, this is just 0. I know at the very beginning, because this light cannot make it through the first filter. It's automatically blocked. Or you can start upwards, go through a, well, let's not do that. Let's do an upwards filter and then a horizontal filter. This is also 0. Because once you made it through this first filter, from here to here, the very next step is perpendicular. Automatically, completely blocked, 0 every time. But be very careful, because if you have this example, let's say like this is not 0. Even though this is up and this is horizontal, they're perpendicular, this is not 0. If you do the math, you actually get an answer, which is very weird if you think about it. Because if you have this example, up and then horizontal, everything's blocked. This filter blocks 100% of the light. All the light trying to get through it is blocked. And then I just put something in between. The thing I put in is not more light. It's just something else that blocks light. This filter here blocks light. That's what it does. Yet, if I have light, and I know this filter right here takes it all away, and all I do is insert an extra filter that would take more light away, all of a sudden, it doesn't block all the light anymore. You actually get light coming through now. It's a very, very strange phenomenon. It would be like this. Say you're in your room, you're looking at the wall between your room and the next room. You shine a flashlight at the wall. Obviously, no light gets through the wall. So someone in the other room doesn't see any of your light. But then as you're shining the flashlight at the wall, you get a piece of paper and you put it between the flashlight and the wall, so the piece of paper blocks more light. All of a sudden, someone in the other room sees the light coming through the wall. It's very, very weird. It doesn't make any sense in our normal world. But that's how this works. So number one, what it says is there's some science going on here that we don't understand. And this is things like quantum mechanics try to help us explain. We don't have to worry about why because it's too weird. Just know that it's true. It's a weird thing that happens. And what that means is be careful with this tip. When I say if you have light or two filters or whatever, one right after the other that are perpendicular, you automatically know the answer is 0. You don't even have to work it out. But be careful, because what I say is the one step right after the next is perpendicular. In this case here, I have this guy is vertical, this guy is horizontal, but there's a step in between. Now I can't use that trick anymore. It's not 0. I have to do the math and I'll get a number. But from one step to the next, if they're perpendicular and there's nothing in between, the answer will be 0, no matter what came after it and what came before it. That's just a trick to save some time. If you're afraid you'll use it in a place you're not supposed to and get a wrong answer, don't worry about it. Always do the math. If you always do the cosine squareds, it'll give you a 0 as the answer. You don't have to worry. But for those that are comfortable with it and you know when to use it, it'll save some time so you don't have to work out problems for no reason. If you know the answer is 0, just write 0. If you're unsure, do the math. If it's 0, you'll get 0 as an answer. If it's not, you'll get an answer. But that's why it's called a trick. It's a shortcut if you know when to use it. Law of Malice always works, so you should always use it. If you're comfortable and you know when things are 0 by looking at it, go ahead and just write it. So that's polarization. Next time, I'll do a couple of examples just to make sure, give everybody a chance to ask questions and stuff about it, but we'll do a couple more examples and then we'll move on to the next piece of optics. This is as far as we go with polarization. So if you can handle these examples, then homework and test questions on it will be just like this. You're given light, here's some polarizing filters, what comes out? So anyway, don't forget about tomorrow's research thing, starts at 9 in PSB. So come on by, they have refreshments and stuff, and then you can listen to some interesting research presentations and such. And then Wednesday, we will continue our talk about optics. So I will see you then.